In previous session, we discussed different study designs, and in this session, we will study the sampling methodology and sample size. And before that, I want to cover a few concepts that were left in previous session of study design. So this is where I start from. There are different types of measurements in descriptive and in analytical studies. Here we estimate either population proportion or population mean. When we talk about proportion, it may be including prevalence or incidence. There's a slight difference between these two. For example, percentage of people who have high blood pressure in our study, and mean may be, for example, the mean blood pressure of our study subjects. Then in analytical studies, we are interested in hypothesis testing using some tests of significance. Second thing is the strength of relationship using odds ratio, relative risk, and correlation regression that we will discuss in biostatistics. Now first understand the difference between prevalence and incidence. Prevalence includes old and new cases, and incidence means only the new cases. To find out prevalence, we conduct cross-sectional surveys, and to find incidence, to do longitudinal studies. Longitudinal studies means that we take the patients, enroll them in our study, and we follow them in future, and we observe developing disease outcomes, and that will be the incidence of the outcome. In cross-sectional survey, we basically find out the number of people who are having a disease, and we are counting all the cases, whether they were old enough cases or newly developed, because newly developed cases counting can be only possible if the people who developed case were under our observation. So that needs to be proved by your own observation, and that counting of new cases can be only possible with longitudinal studies where people are under your observation. If in longitudinal studies you restrict yourself to finding incidents only, that will be a descriptive longitudinal study. However, we studied that cohort studies are also called longitudinal studies, and those are analytical. Uh, why we call them analytical? Because in cohort studies, those are also longitudinal. They do not stick to finding incidents only. They find incidents as well as odds ratio, the measures of association and relationship between the two variables. And I will now show you a few studies, cross-sectional survey and descriptive longitudinal studies. And I could barely found some examples because usually researchers, when they conduct longitudinal studies and do the follow-up of patients, that is very costly, and they try to then perform as much as calculations they can. They prefer to find some relationship also between the variables. Now this is what I want to show you, an example of a descriptive longitudinal study. Experience of COVID-19 patients in ICU. The researcher had this data available of COVID-19 patients, and the researcher then decided to publish it, and it could be published as a descriptive longitudinal study. and not as a case series, although COVID-19 was a new disease and new diseases can be presented using this case series, but because they had the data of many patients. You see, this is N is 45, that is, they had 45 patients data, and so they could publish it as a longitudinal descriptive study. So what they do is they record how many of these patients develop what kind of complications in this table. Here you can see acute kidney injury in 26 patients, and this can be said to be the incidence of acute kidney injury in COVID-19 patients. But they do not use this term of incidence in this article because they are basically describing all the events and not just interested in one complication. If they were interested in one complication only, they would have titled this article as the incidence of acute kidney injury in COVID-19 patients, a longitudinal descriptive study. However, they have made the title as experience in management of severely ill COVID-19 patients. So this was one example of descriptive longitudinal study. I now want to show you a cross-sectional study that is analytical. You will come across many descriptive cross-sectional studies where they find prevalence of um, some disease, but you will not get to see many analytical cross-sectional studies. Let's see how they did it. Okay, going to methods. So they surveyed 300 students, calculated the sample size, used standard questionnaire, and they measured um, fast food consumption, that was the risk factor, and they measured the outcome, that was obesity, using obesity indexes, and then they related both these variables. This was the test of significance that was used to find the relationship between these variables, and they named the study as fast food consumption and overweight obesity prevalence in students and its association with general and abdominal obesity. They have found relationship between a risk factor and an outcome. But there is no hypothesis written in analytical cross-sectional study. Okay, so now I will discuss sampling. Sampling uh, includes sampling technique, inclusion-exclusion criteria, and the sample size. So first of all, I will describe what is a sample. A sample is a subset of the population with all its inherent qualities. Inferences about the population can be made from the measurements taken from a sample if the sample is truly representative of the population. Since a sample is expected to represent the whole population, the sampling procedure has to follow three fundamentals. It should be representative, it should be large enough, and the selected element should have been properly approached, included, and interviewed. First of all, I will discuss how large enough the sample should be. It should not be too small to compromise the accuracy of results. If the sample size is very small, the quality and the accuracy of our evidence is lowered. And then the sample size should not be too large to waste resources. That is our time and our money. And for hypothesis testing, it should be large enough to prove a hypothesis at a certain level of confidence. Therefore, we calculate our sample size, and the calculation gives us the minimum sample size that is required. For sample size calculation, we need to know our type of study design. So we should have decided our study design first. We should be having some statistics regarding the prevalence of our disease from previous studies. Then we should know what type of statistical analysis we will perform in our study. We should decide some level of significance and power of the test. We should decide our sampling technique, and we should know what response rate we will get from our study. And for that, we can do some pilot testing of our questionnaire. And in case of longitudinal study or follow-up studies like experimental studies, we should have an idea of how many loss to follow-ups can be there in our study. So beforehand, we should have all these parameters at hand. These are the two most commonly used formulas that apply when you are interested in finding population mean or proportion in your study. Another easy method is to use online calculators that are available. Many of them are free, and I use this OpenAPI software. As I already told you that you should have already available statistics regarding prevalence of your outcome of interest from previous studies. To do if it is not available and unknown, then you should use P is equal to 0.5, that is 50% prevalence. Why? Because it gives us the maximum sample size. If you see this formula, you can see here PQ written here. The higher this value PQ is, the higher will be your sample size. PQ is basically the variance, and P is the prevalence, that is the proportion. If it is 50%, P will be 0.5, and Q means 1 minus P. That is for 0.5 P, it will be 0.5 Q. So checking here for population proportion 0.5, what will be the value of PQ? It will be 0.25. So you can see that's the maximum variance, and the maximum value here will give the maximum sample size here. And the maximum sample size is basically the safest option when you do not know the prevalence. And the farther it is away from the central value of proportion, the lower will be the variance on both sides. Then there is a term called as effect size, also called precision or bound and error. Okay, so you can see this denominator B, bound and error. This is the effect size, and in previous formula, this is the mean sample size for population mean. This is written here E. This is same as bound and error. You can write it as E or B. This represents the effect size. The higher the effect size, the lower will be your sample size because it is in the denominator. You can well understand this. What it actually is, it is the difference that needs to be detected between two groups by the researcher to prove hypothesis. One group, it will be the difference that needs to be detected to estimate the population proportion or the mean. And this has to be decided by the researcher, and it depends on what the researcher believes is the clinically meaningful or biologically credible difference that should be detected. Solve a few examples next in our next session.